3D solids. There is some terminology that we need to be aware of when dealing with 3D solids. So if we consider this cube here, a corner here is called a vertex. One of these lines that goes between two vertices is called an edge. And the area on one of the sides here is called a face. We are often asked to count the number of vertices, edges and faces of a 3D solid. So let's consider the cube again. We know this is a vertex and we can see other vertices here. And if we count them, we find that there are 8 vertices. Now let's consider the edges. So I've got one here, one here, one here, and one here. That's 4. I can see these ones as well. There's 4 of those, and I can see that I've got 4 left going around the shape, giving me a total of 12 edges. I can see a face at the back here, and if I try to draw more of those on the same diagram, it'll end up being a mess. But there's one at the top, one at the bottom, the 2 sides and the front, giving a total of 6 faces. There is a formula we can use to check our results. It's called Euler's formula, and it says the number of faces added to the number of vertices is equal to the number of edges plus 2. If we try it for this shape, we get 6 plus 8 being equal to 12 plus 2. So both of those are 14. But note, this only applies to 3D solids where the faces are polygons like triangles, squares, pentagons, etc. I'll point out to you shapes where this will not hold. There are some 3D shapes that we need to be able to name. I'm going to go through them here. This one is a cube. All of the edges are the same length in a cube. This is called a cuboid, or some people refer to it as a rectangular prism. All of the faces are rectangles. In fact, some of them can be squares, but not all of them. If all of them are squares, then we have a cube. These are prisms. A prism is a shape that has a cross-section which is the same all the way through a shape. So we get some sort of end shape like a triangle or a rectangle, and then all of the other faces that go around the shape are rectangles. In this case, these are triangular prisms because the ends are triangles. In this case, a right-angled triangle at the end here, and in this case we have some sort of isosceles triangle. This is a hexagonal prism because the end is a hexagon. And here we have a trapezoidal prism. It should be clear that there can be lots and lots of different types of prisms. You just have a different shape at the end. This is a square-based pyramid. The base is a square and then we taper to a point. So unlike a prism, it tapers to a point rather than having the same square all the way through the shape. This is a triangular-based pyramid. If all the faces are equilateral triangles, this is known as a tetrahedron. This shape here is a cylinder. We have 2 circular ends and a curved surface. Now for this shape, it won't follow that Euler formula, F plus V is equal to A plus 2. that doesn't apply to the shapes with curved edges. This you should recognize as a sphere. And here we have a cone. As I've mentioned, these last three shapes have curved surfaces, so do not follow f plus v equals e plus 2. Or at least not necessarily. You might find ones that do.